14 is a revenue problem, and it tells us that hockey sticks sell at $120 per stick, and at 200 sticks, and they'll sell 200 sticks at that price. If they decrease the price by $3, they increase the sales by 10 sticks. So first of all, what's the equation for revenue? So the equation for revenue is going to be price times number sold. So revenue equals the price times the number of items sold. Okay, so that's our equation for revenue. That's a calculation for revenue. Now we want to make this a function as we change the revenue, or as we change the price and the sticks, the number of sticks, we should have the revenue change as well. So to write the equation for that, we want to write it like this: revenue as a function of x. And what x is going to represent is the increases of $3. So we're going to start with a price of $120, and then we're going to increase it by $3 increments. So we're going to do it as 3x. For every x, we add $3. Well, if that's the case, the number sold is going to change. So we're going to start with 200 sold, and as we increase the price by $3, we're going to decrease the number of sticks by 10. And so we're going to do that with groups of x. So for every one x, we're going to go up by $3 and down by 10 sticks. So as we change x, we're going to get different amounts of revenue. And this is in fact a quadratic equation. So to find the max revenue, we really just want the vertex. So I'm going to expand this out. So I'm going to get negative 30 x squared. I'm going to end up with 600 plus 600 minus 1200. So minus 600x as my middle term. And then the constants multiply to plus 24 and then 3 zeros, so 24,000. Okay, so when I don't have any increases of x or decreases of x, I'm going to sell $200 sticks at $120, and that represents actually my y-intercept. So that's why that number ends up there. But that's not what I'm looking for. I'm looking for the max value, so I need to find the vertex. So I'm going to complete the square to find my vertex. So I'm going to factor out the negative 30. So I end up with 20x as my middle term. I'm going to put the 24,000 on the outside. So this is completing the square to find the vertex, which is different than completing the square to solve the equation. So I'm going to take the middle, square it, so I get plus 100. I've added negative 30 groups of 100, which is negative 3,000. So I'm going to balance with a positive 3,000 on this side. So there represents my maximum revenue. So what I want to know is the x that maximizes that revenue. And it looks like, in this case, if I have a negative x, or if I decrease the price and increase the sales, I'll actually get more revenue. Okay, so my vertex is going to be at negative 10 and $27,000. The y value represents the revenue or the dollars involved in this. Now, this is an equation for revenue. The max revenue is going to be 27,000. So when I enter B, that's going to be the vertex value. And the price that guarantees the max revenue is going to be based on x. But this is equal to x. It's not equal to price. So to find the price, I have to go back to my price equation, which is this part of the revenue equation. So then I'm going to write this as price is equal to 120 plus 3x. I know that the X value is going to be -10. So if I decrease the price by $30 to $90, a $90 stick will sell more and it will give us a better price. So the best price that guarantees the maximum revenue is going to be that $90. Okay, so the price that guarantees max revenue is going to be $90. If you want, you can calculate the numbers sold as well based on this part of the equation. So if X is -10, then the number sold works out to be 300 sticks, and that's consistent with what we figured out. $90 at 300 sticks gives us a revenue of $27,000.